do we have here? I'm just going to leave that right there. Bye.
That's actually kind of cute. My wife made me Ziggy the iguana. It's one of the Zig mascots. All right, so let's take a look at what we're going to build today. So we'll look at the architecture. I put together a diagram for us. Let me zoom out. Here's a complete picture. We'll zoom in to start with at the top here. And we're going to be starting with our Godot client. So we're going to be using Godot, as I mentioned before. This is an open source, lightweight game engine. Very good. I much prefer it to Unity. And we'll kind of introduce various aspects of Godot as we continue through the series. But for today, just know that it's our client. That's how the players will actually interact with the game and connect to the server. So our Godot client is going to be reaching out to an authentication service. And this could be a microservice. It could be just a small part of our Zig server, which is what it will likely end up being. We're just going to spoof this during the first few episodes. We don't need it now. It's something we can introduce later. But the point of that is that we reach out, we authenticate, we send a username and password, for example, and then we get a token if our credentials were valid. And then we pass that token along to our main Zig server here. We come down, and this is our socket connector. So we're going to be using TCP as our connection protocol, transmission control protocol for reliability of packet delivery. We're not going to be using kind of a high-level abstraction like WebSockets or anything like that. We're going to get low-level, and we're going to handle all the communication ourselves. So yes, this is our socket connector. This is going to be listening continuously while the server is running for new connections. It's going to be validating tokens, and then once it does that, it will actually spawn a new thread for each player, and that thread is going to be our socket listener. And that listener is going to listen for messages from our various Godot clients, our connected players, and those clients are going to be sending updates and commands, things like that. And our socket listener is going to be constantly spinning, listening for those. And when it gets them, when it receives them, it's going to be pushing them to a shared queue, our inbound message queue. And this is a shared queue, which is built in a way that it can be used concurrently across many different threads. And we'll talk about that later. I don't want to overwhelm anyone. We'll introduce these concepts very gradually. And that message queue is going to be constantly read from by an inbound thread pool, a collection of threads that are just kind of saying, hey, give me a message, and then they process that message, and they send that message over to our client action router. And our action router basically is going to convert those client messages into game logic. Obviously, we'll perform validation and stuff along the way, but I'm just speaking generalities here. And then here in the bottom right, we have our internal game logic. I'm just representing that as a black box for the purposes of this diagram. But those actions are going to be routed into there. And what's going to come out are updates to send back to the clients. So the players need to know where they are in the game world. They might need to know where other players are, where mobiles are, enemies, NPCs, things like that. They might need to know the results of their actions. So those will be spit out into an outbound message queue. And then we have an outbound thread pool that's constantly reading from that. And that will shuttle those messages back up to all of our various connected Godot clients based on the messages. So based on to whom those messages are addressed, we should say. So at a high level, that's what we're going to build. And today we'll be focused on this first part. So we'll start with our Zig server. We'll go ahead and install Zig, introduce Zig. We'll get our socket connector set up, and then our socket listener. And then to finish off the day, we're actually going to download and install Godot, and we're going to connect Godot as our client to our server. And we're going to pass messages back and forth. We'll see how far we get with that. But yeah, that's the plan. Let's get started. All right, so let's get started. First thing we need to do is install Zig. I went ahead and got rid of the webcam. I'm using GPU screen recorder now. By the way, I got a new mic. I think it sounds a lot better. This is a Samsung. But yeah, excited. Trying to improve the quality of the channel. Anyways, so let's install Zig. Go to zigling.org. And from here, you can actually download the Zig programming language. We'll download the binaries. But before I do that, just wanted to shout out to Zig. Like I said, you can read more about it here. But it's awesome. It's a decentralized community. It's run, managed, and operated by a 501c3 nonprofit corporation led up by Andrew Kelly and the board of directors. I've listened to a few of his talks on YouTube. Really inspiring. I really like his vision for the language and kind of how to shape it. It does have some industry adoption so far. One of the coolest is this, I think it's a financial systems database called Tiger Beetle. Extremely performant, really cool stuff. So check that out. But anyways, as far as installing it, go to the downloads page. One thing to note here is that at the top, you'll see the master branch. So this is essentially, these are the daily, nightly builds. These are the nightly builds. We don't want to use these for the purposes of this video. The language is young, like I said. There can be breaking changes between versions. So we're going to stick to the most recent stable build, which is 0.13.0. So this way, everything will work the same between your system and mine. So let's just kind of settle on that version. We'll probably upgrade the project if 0.14.0 comes out relatively soon, but we'll cover that, so don't worry. So just grab this one, and based on your processor architecture and operating system, just go ahead and grab the appropriate binary and add it to your path. So if you don't know what that means, don't worry, I've got some options for you. One of them is to go to zig.guide, which is a very nice reference for Zig. Go to the installation tab here, and there's different little tab header menus here for your operating system. You can follow those steps. For me on Linux, pretty easy. I just grab the binary, put it where I want it, unzip it, and then export that path to my bash RC path. So that works. Just to confirm, you would just go something like this, right? Zig version 0.13.0. That's what you should see. Okay, so follow the instructions for your operating system. If that's still a little bit too much for you, which, I don't blame you. That's, if you've never done this stuff before, it can be a little confusing. Just grab VS Code or Visual Studio Code. Very common tool. You should be familiar with it. And this one actually has the Zig community. I think this is an official extension. Zig language here. So this is by the Zig Foundation. This is the official plugin for VS Code. And this is a batteries included plugin or extension. Just install it. It includes the Zig binaries. It includes the Zig language server, ZLS, which you would have to install separately otherwise. So just go ahead and click install on this. You'll be good to go, and then you'll be ready to follow along. Okay, so now that we have Zig installed, what we need to do is go ahead and set up our project. So open your file manager, your file explorer, depending on which operating system you're in. That's Dolphin for me on KDE Linux. And what we'll want to do is go to wherever you want to create your project. I'll just create it in Documents. And then you want to open a terminal here. So open a terminal at that path, and we'll do make dir Zig indie MMO, and that will create our directory. We'll jump into it. And then all we have to do to kind of initialize the Zig project is type zig init. And that will go ahead and initialize the project. And if we close our terminal, jump back into our file manager, let's go ahead and open that with VS Code. So we've opened that. You'll want to trust the authors if it asks you. Don't worry about that. And you'll see it actually went ahead and created a bunch of files for you. So we have our build.zig, our build.zig.xon. We'll talk about that stuff later. That's related to the Zig build system, but we really don't need to mess with that at all for now. You'll also see a source folder, and this is where your actual source code will go, your Zig code. So we have a root.zig, and this is created as kind of like this shows you how to set up a library and to do tests. So we'll actually just go ahead and blow that one away. We don't need that. We're not creating a library, we're creating a binary project. And then it also creates a main.zig for you. This is where your actual program, or in our case, our server code will go. So we have our public function main here. That's the switchboard or the entry point to our application. And yeah, this is where we're going to be writing our code. So just to kind of show you how to run a Zig project really quickly, we'll pop open the terminal and we'll jump in here and we'll do zig run source main.zig. And that's going to go ahead and build. And you see this is just a Hello World app to start with, and it just says all your code base belong to us. So yeah, that's the basics of how to set up a Zig project, how to run it and build it in debug mode and run. And yeah, we'll cover the rest of that stuff in great detail later when we're ready to kind of finish up our project and go ahead and deploy it to a server. But for now, let's get started. So we'll have to go ahead and get rid of everything here in main. We'll erase this example test that Zig provides, and we'll start coding. So at the top here, you'll see I have an import statement. This is how Zig handles imports. You assign them to constant values. So here, const standard equals add import std. This imports the standard library, and then you can access components of that standard library with standard dot, with the dot notation. All right, so we need to create our TCP connector. We need to listen for incoming TCP connections. And let me blow that up a little bit. Let me know in the comments if this is a good size for everyone. I don't want it to be too big. Probably scale the UI about there, and we'll go ahead and get rid of this. Maybe we'll go one more. Close the terminal. Okay, so let's get started. So what we need to do is go ahead and import the net library. So that's part of standard. Just for convenience's sake, we'll write it like this: const net equals standard.net. All right, so let's start with the first part. I'll go ahead and paste in some code that I've already written. And this is kind of how I'm going to proceed for now. I'll be pasting kind of chunks of code and then explaining them step by step. I think that's better than me just sitting here and writing that out line by line, but you can let me know in the comments what you prefer. So here what we're doing is we're defining an address and we're resolving that. We want to listen against all IPs, and we want to bind to socket 1337. And that can be whatever you want. In this case, thought it was funny, but also this is kind of what we're going to be going with. So here we are now, and you might notice this line here, catch unreachable, and that can be kind of confusing. So let me just take this opportunity to explain how Zig does error handling. So if we look up here in pub function main, our main function, you'll notice that void has a bang or an exclamation mark in front of it. What that means is that this function can return an error. So what that basically means is that the calling code has to deal with that error. So it must handle it. So if we're just bubbling that, let's say we just want to bubble that error up, instead of doing catch unreachable here, what we could do is const address equals try net.address.resolve IP, and that will go ahead and try. And in Zig, try actually, it's not like try catch in other languages. Try will just bubble up the error. So in this case, not in main, but let's say if this were a function being called from elsewhere, that function would then have to deal with that error. We're not necessarily handling it right here. But for this one, we know this is either going to succeed, and if it doesn't succeed, we probably just want to kind of crash the program. So what we can do here is catch and unreachable. That's just something we can use to say, especially for development and debugging, hey, this pretty much is never going to happen, so let's just proceed. I would venture to say that if we can't resolve this and bind to this address and socket, and port, we probably just want to end execution. So maybe we would do something like catch and then say at panic. So we can panic in Zig, just like in other languages like Rust, that just ends execution of the program. So we might say failed to bind to address, and we just want to stop running the program. Okay, so there we go. And then on the next line, what we're doing is we're going to be listening at that address. So we're going to go ahead and do that. We're going to pass in the default listen option struct here. And for this one, we'll just do the catch unreachable for now. And you'll notice I have an error here, unused local variable. In Zig, you have to use I believe they're called objects officially, but whether it's a variable or a constant, you have to use it. Otherwise, Zig will throw an error and it won't build. So just a note there. So VS Code is really nice and it helps us. And this third line, this is just how you do debugs and prints in Zig. You'll notice this here. I was confused about this at first. That's an anonymous struct, and that's how we pass in options here. So let's say maybe I wanted to kind of embed a string into this, to this print statement. I would just do that, and then I could, for example, do test, and it would print that there. What we'll do next is a defer server.init, sorry. So here we'll be kind of deinitializing that server. And what defer does is it defers execution of this line of code until this particular portion goes out of scope. So in that case, that would be the end of execution of main. We'll be deinitting our server. All right, for the next bit here, we've set up our server. We're listening. Now we're going to run in an infinite loop. We just want it to keep spinning. We're going to accept new connections on that server that we've defined. So here, while true, we're just defining connections. We're storing in this connection constant, we're storing the return value of server.accept, which if we mouse over, ZLS tells us is a connection object. So that's basically a TCP stream. That's what will be returned. And then we're doing a catch again, that Zig error handling. And if that fails and returns an error, we'll just go ahead and print to the console, and then we'll continue and try to keep listening for new connections and accepting them. So very straightforward so far. And what you'll notice though is we're just kind of accepting the connection and we're not doing anything with it. So what we can do now is actually listen. Once we've established that connection, we can start listening for messages from the client. Okay, now that we have our connection established, we'll go ahead and do the next step, which is going to be listening on that socket stream for incoming messages. So we'll define a buffer, and that is going to be an array of U8 values. That is unsigned integers, positive integers. This is how strings are represented in Zig. There's no built-in type for it. So essentially they're arrays of bytes. In our case, we want our buffer to be of length 32, so 32 bytes. And we're going to start that off as undefined. And then we're just going to loop through forever. And as we're looping through, what we're going to be doing is saying const bytes equals, as part of this stream object here, we're going to call the read all function, which is going to try to read until it fills the buffer. So our buffer length of 32, it's going to read until it fills that. You can see we're passing in a reference to our buffer here. So this is how references are represented in Zig. We have our ampersand. And yeah, it's going to read until it fills the buffer. And it's going to return the amount of bytes that were read. And that's what we're storing in const bytes. So then we can just check to see, is that greater than 0? Yep. And we're going to go ahead and print out the message we received. So in this case, we're going to do a bit of string formatting here, right? Received D for number formatting, bytes, and then a new line, of course, and then the actual bytes we received as a string. And then you can see here we're passing in the parameters to that print string. So the first one being bytes, the number, that's how many we read, and then the actual message, which is going to be our buffer. So from 0 to total bytes read. So all 32 there. And yeah, so this will actually print out messages as we receive them. So there's a lot of drawbacks. This is not by any means going to be in our final program. This is a very naive and brute force way to kind of do this socket implementation here. But I just want to kind of start easy. So what this will do actually is block forever. So these are blocking operations. So as we go ahead here and start listening for connections and then listening on that individual socket once we've defined it, this is blocking. So only one client at any one time can connect here. So we'll have to work together, kind of solve that. How can we support multiple clients? And how can we clean this up? Because it's getting kind of messy, right? With all these nested while loops and such. But before we do that, let's take this time to go ahead and see if this program runs. So I'll go here and we'll try Zig run source.main, and we have an error. So you'll be working with the Zig compiler a lot to kind of resolve your errors, and it will be very helpful in that sense. This just turned out to be, I think, an error from code I had in before, which I've already removed. So let's go ahead and run. And nope, we've got another one. So that's just me being a doofus, and I forgot that. I'm kind of like retroactively deconstructing and rebuilding this app in a more simple way. So you'll see kind of where that abstraction comes from later, but we just need to remove that. It's actually on the connection object. We have a stream, and that stream is what contains everything. So if we go ahead and clear that, save the file, we should be able to run that, and you'll see that it builds. It builds, and then we're listening for clients. So the server's spinning, it's listening, we're good to go. Now what we're going to do is we're actually going to install Godot, and we're going to attempt to connect. Okay, so to install Godot, just go ahead and search for it in your browser. I believe it's godotengine.org, but you can also just do a quick search. Yeah, here it is, godotengine.org. We're going to be using version 4.3, which is the latest version, so we're on the latest and greatest. You'll just want to go to download latest and go ahead and download it for your operating system. It should kind of auto-detect that. Go ahead and grab it. It'll download. Yeah, so with Godot, like I said, it's just a binary, so just open it up. You'll see it's just literally just an executable. You can extract that, put it anywhere you want, and then just double click it to run, and you're good to go. I've already got it installed, so for me, I'll just go ahead and pop it open. Okay, so now we'll create a new project. Go to create. I will create it next to the Zig project I created earlier, so I'll select my documents folder, then just go ahead and give it a name. We'll call it Zig Indie MMO Client. And make sure create folder is checked, and then go ahead and create an edit. So the renderer here, you can leave that on forward plus. That's the most kind of performant one, most advanced, because I don't think we're going to be doing a web build. I think we want to do a thick client build. We'll just go with that, but there are other options. So go with create an edit. What that will do is create your project, and then it will open the Godot editor. Okay, so once we're inside Godot, you'll see this on the left side kind of greeting you, asking you to take an action. You'll want to create a root node as a 3D scene because our game will be a 3D game. So we'll create our root node 3D. We have a node 3D here. This is not going to be an overview of Godot, but I'll just kind of teach you as we go what things are. If you've never used a game engine before, there's quite a bit to learn, but I think the best way to learn is just by doing things hands-on. And I'll try to keep the client Godot stuff as minimal as I can. Really, the focus of this project is going to be the Zig server. So we'll just do kind of the minimum we need to be able to see what we're doing on screen and be able to play with it from the client perspective. So with that in mind, let's get started. Okay, so I have my node 3D here. What I'll need to do is, we're not going to represent that in any way as a 3D model or anything at this point. What we want to do is just kind of save this scene. So this is our default scene. We'll go ahead and save that. Let's call it sandbox and go ahead and save that. It'll save into the root resources directory by default. We've done that. Now click on our node 3D and then click here. Click this attach a new script. What we're going to do now is just kind of create a test script. So we'll call this our client underscore test.gd. Click create or press enter. Here's our basic script in Godot. Scripts are structured this way for all nodes. You have a ready function. Think of it as a game loop, right? Ready runs when the object is created. Process runs every tick or every kind of iteration of that game loop. And then it passes in a delta time, which is the amount of time that has elapsed since the last run. Anyways, probably way too much information for now. What we'll do is just kind of focus on getting a super basic TCP client set up. So let's get started. Okay, so before we jump into the code here in Godot, just wanted to take a moment to get you familiar with how Godot works. So Godot uses what's called GD script. It's a domain-specific language specifically for Godot that has bindings to kind of the game engine itself, which is written in C++. It's a very easy language to learn. It's very Python-like in that it uses tabs to define blocks of code like functions and conditionals and if statements and all that. So very easy to learn. It's probably my favorite domain-specific language of all time. It's just an absolute pleasure to learn. So I'll stop gushing about Godot and let's get started. So what we'll do first is we'll define a stream peer TCP. So we'll store that in a variable called client, and we'll do that up here. So it's accessible throughout our entire script here. And the stream peer TCP is a built-in Godot class or object. And in Godot, you actually have built-in documentation. So if you hold control, you'll see your cursor changes. You can click on the built-in types and you can access the built-in documentation just like that and kind of read through it. Very nice, very, very handy. In Zig, we actually have to read the source code or go to zig.guide and kind of read what's been documented there. But yeah, Godot is really nice in that regard. Okay, so what we'll do next is we're just going to kind of wait a second. We're going to do a sleep for a second. Don't worry about the syntax here. We'll talk about that later, what that's actually doing. And then we're going to define a function called connect to server, and we'll do that at the bottom. And what this is going to do is initialize our client variable. So our client that we defined up here, we're going to go ahead and initialize it. We'll create a new stream TCP peer object. we'll then try to connect to a host. So in this case, localhost on port 1337, which, if you'll recall, is what we defined in our Zig code here. We're listening on port 1337, and we're listening on all addresses. So localhost port 1337, we're going to try to connect. That will return an error object. If that error does not equal OK, which means something bad happened or something unexpected, we'll go ahead and print that error out. This is all just placeholder. We want to get this up and running. I want to show you the magic, Okay, so next what we'll do is we will, in our process function, if our client is null, so the process function is running every frame, so it's constantly ticking. And this is part of the game loop in Godot. You'll be familiar with this if you ever used a game engine like Unity. They all have some form of process or update function. So if client is null, we just want to return. We don't want to run anything. But if we do have a client reference, we want to go ahead and do client.poll, which will update the state of our TCP client. Okay, so now that the state's updated, what we'll do is we'll check to see the status of that client. So we'll use the getStatus function, which will return an enum value. And if that does not equal status connected, that means, we don't want to process anything. We don't have an active connection at that point. So let's just get out. Now, where we'll actually send data to the server, we don't just want to spam it. I don't want to create thousands of log messages here. What we'll do is I'll introduce you to the concept of nodes in Godot. So if I come up here and click the plus icon or press Control A, I can add a timer node. So here, these are all Godot's different types of nodes. There's many of them. We'll get familiar with a few of them, but this is more of a server-focused project, but we will do a bit on the Godot side. What we'll do here, though, is we'll create a timer, and actually already had one. This timer here, we want to set the wait time to 3 seconds. We want to make sure it is not one shot, and we want it to auto start. So we want to kind of start automatically. What this means is this is going to run, it's going to count down to 3 seconds. Each time that happens, it's going to emit a signal called timeout. So if we click here on node, what we can do is, I'll go ahead and remove the one I created earlier. We can see all of these. These are the signals for this timer. These are built in by Godot. The timer specifically has a timeout signal. So if we double click that, we'll get a nice little dialog here asking us if we want to add a method, a receiver method for this signal. And we do, and it will actually create code for us on timer timeout. And we'll choose this node, this script, press connect. You'll see it actually generated code for us here and connected it to this signal. The icon changed. So this code is actually going to run each time this timer counts down from 3 seconds. So it's going to run some bit of code that we define here every 3 seconds. So what we'll do is we'll take advantage of that to ping the server. So I'll go ahead and paste in some code here. Again, we have a guard in place here. If we don't have an active connection status, we'll just return and ignore this. But if we do, what we'll do is we'll use the put data function of our TCP stream peer client, and we'll send a message. So hello from Godot, packet padding. We want to make sure that this message is 32 bytes because that's our frame size. And we'll convert that to a UTF-8 buffer. So this will be a 32 byte message, UTF-8 encoded, which is perfect for Zig because Zig handles string data as UTF-8. So this will play perfectly with that. So we're going to go ahead and send that to the server. Okay, so we can actually go ahead and save this and run it. Okay, so let's go ahead and start our Zig client if you haven't already. So Zig run source/main.zig. Make sure you're in your project directory. Go ahead and click that. Okay, so we're listening for clients. Make sure you see that message. Make sure the project's actually running, right? And then we'll jump over to our Godot project. We'll click play. And it's going to ask you, hey, I don't know which scene to run. You haven't assigned a kind of a default scene. So what we'll say is just select current, which is the current scene we're in. And it's going to go ahead and run. And you're not really going to see anything in the game window because there's no camera, there's no world environment or anything. But what we'll do is we'll minimize that and we'll go look at our terminal on our server. And you can see we're actually receiving messages. So received 32 bytes, hello from Godot, packet padding. So that's just to make sure the packet's 32 bytes, right? And we'll talk about that later, how we're going to handle that. But yeah, so you're going to see that just kind of continuously receiving new messages. Like I said, so look, we've created a basic client server connection using TCP with Godot and Zig. Pretty cool. It's a really good foundation to build on. And like I said, the really big downfall or kind of drawback of what we're doing here, first of all, it's messy, right? We've got everything in main. So let me kind of minimize this. We've got everything in main, and we've got nested, like double nested loops here, and it's single threaded. So we can only accept one client connection at a time, and we can only listen to one stream at a time. So very limited, would not work for an MMO unless it's just a 2-player co-op, local co-op game or something like that. So what we need to do is we need to introduce a multi-threaded model, a more sophisticated model, so that we can accept multiple connections, kind of shuttle them along, and be able to listen to all of them at the same time. So that's what we'll be working on next. So I hope you enjoyed this episode. This is a really good foundation, very basic, but I just wanted to kind of lay the foundation, and really excited for this series. So if you like it, please subscribe, please like the video, leave me some comments below if you found anything confusing. I'm happy to help out. But yeah, really looking forward to proceeding with this series. Take care, everyone.